Let's see how we can solve this Olympiad problem. It says x plus x times y plus y is equal to 76. And x and y are given to be positive integers. We need to find what x plus y is equal to. Let's get started. We have x plus x times y plus y is equal to 76 given. What we need is to find x plus y is equal to what? It is given that x and y are positive integers. We may need that in finding what x plus y is equal to later on. We have only one equation and two variables in it, x and y. So how to find what x plus y is equal to? Let's see if we can write this left-hand side in factored form as a product equals a value form. Then with this additional information given, it may help us logically reason it out to find what x plus y is equal to. So let's try to write this left-hand side in the factored form as a product of terms is equal to a value form. How to write this left-hand side in that factored form? If we look these first two terms, we see one x term is common for these. Let's try to take that common x out of the two terms. Then another one should be remaining there and plus y should be remaining here. Plus that y is still there. And on the right hand side, we have 76. Now still it is not in that product equals value form. But if you look at here, we have 1 plus y and here only y. If we can create the same factor 1 plus y here as well, that factor will be common for both the terms and can be taken out in the next step. And that will help us further factoring the left-hand side. So let's try to write here the same factor 1 plus y. We write 1 plus y here by adding 1 to that y. We cannot simply add to one side a value. To continue with the equality, we need to add the same to the other side as well. So I'll add same to the other side as well. Now we have 1 plus y here as well. We can put parentheses around, it's the same thing. And we see that for these two terms now 1 plus y is common. We can take that 1 plus y common term out of these two terms now. Then what is remaining here is simply x, and here it will be plus 1. We can double check by distributing, by multiplying by this, both these terms, we get 1 plus y times x, which is that. 1 plus y times plus 1, which will be that. So nothing wrong with writing it like this, taking the common terms out. Then on the right hand side, it is simply 77. Now we have a product equals value form. And with this additional information given, it may help us to logically reason it and find what x plus y is equal to. Let me write this like this: 1 plus x, this term first, x plus 1 is same as 1 plus x, and then the other term 1 plus y is equal to 77. And because it is given x and y are positive integers, then x should be greater than or equal to 1 and y should be greater than or equal to 1. If x is greater than or equal to 1, 1 plus x should be greater than or equal to 2, because if this is greater than or equal to 1, adding 1 to that should be greater than or equal to 2. Same here, because y is greater than or equal to 1, because it's a positive integer. 1 plus y should be greater than or equal to 2. Now we have a product of two positive integers which are greater than or equal to 2 is equal to 77. And we need to find what x plus y is equal to. Let's see if we can figure out what 1 plus x and 1 plus y should be equal to first. Then we can find what x plus y is equal to. In order to find what 1 plus x and 1 plus y should be, let's try to write down all the factors of integer factors of 77. In other words, integer products that give me 77. Let's write those down, and then it'll help us to logical reason it and find what 1 plus x and 1 plus y, these integer terms, should be. So 77, we can get that by multiplying 1 and 77. Also, we can get that by multiplying. Now, if we try to continue to write all the products that we can, like 1 times 77 and 2 times no integer will give 77. Same way, if we can continue to write 3 times, it won't give any. 4 times again, 4 times no integer will give 77. Therefore, if we keep on writing like that, the next one that will give us 77 will be 7 times 11. And then again, 8 times, 9 times, we keep on writing, we won't get 10 times, 11 times, again we will get 11 times 7 is 77. And if we keep on writing 12 times, 13 times, 14 times, 15 times, those will not give. And we will see that again, 77 times 1 will give us 77. So we have 4 integer products, positive integer products that give 77. Out of these integer products, we know 1 plus x should be greater than or equal to 2 and 1 plus y should be greater than or equal to 2. So out of these 4 integer products, we see that it cannot be this, because then one of the numbers is 1, which is not greater than or equal to 2. So it cannot be. Same here, we need 1 plus x and 1 plus y to be greater than or equal to 2. Those should give when we multiply 77, and these will give when we multiply 77, but here again we have 1, which is not greater than or equal to 2. So cannot be 1 plus x or 1 plus y, this. Therefore, that factor won't work. Then only possibilities are 1 plus x to be 7 and 1 plus y to be 11, or 1 plus x to be 11 and 1 plus y to be 7. Let's write those down. So 1 plus x should be 7 and 1 plus y should be 11, or 1 plus x should be 11 and 1 plus y should be 7. This option and that option. And what we need is what x plus y is. We can do it in a couple of ways, like from these we can find, if we choose this option, what our x would be and what our y would be, and then plug them in and simplify to get same way from here as well under that option and see what we get. If not, I can rewrite this with adding 1 to x and also 1 to y and subtracting the 2 that I added. And then 1 plus x and 1 plus y, we already know. If we choose this option, 1 plus x is 7 and 1 plus y is 11 minus 2. It will be 18 minus 2, which is 16. If we choose this option, 1 plus x is 11 and 1 plus y is 7. Again, 11 plus 7 will be 18, minus 2 is 16. So either option will give us the same value, 16. We can always double check, if we use this option, from this we can find what x is by subtracting 1, and it will be 6. And from this we can find what y is by subtracting 1. It will be 10 that we get, because 11 minus 1 is 10. And if we choose these to be x and y values, clearly they are positive integers, so that condition is satisfied. And we can double check if it satisfies this equation given as well. X is equal to 6 plus x is 6 times y is 10 plus y is 10. So we get 6 times 10, which is 60. 60 plus 10 is 70, plus that 6 is 76. So these numbers for x and y satisfies the requirement. So these are correct. Same way, from this choice 2, we can easily find x will be 10, and from this y will be 6. Again, we plug them in here. 10 for x, it will be 10 plus 10 times 6 for y, plus again another 6. 60 plus 10, 70 plus that 6, 76. So these again satisfy. Therefore, what we have for x, y under any of the two options is correct, and as a result, x plus y value will be correct. So this will be the correct answer. Like that, we can solve that Olympiad problem. Hope you learned something from this, and please subscribe my channel as well. I will see you again with another similar video. Thank you.